All right, well, welcome everybody. Glad to see the good turnout. Do we need to do a sign-up sheet?
Nah, Janelle's not here, we won't.
Okay, all right, well, okay. I was kind of hoping she'd be here just to see what the deal is with, what is it, Saturday night there's people coming? Unfortunately, I'm gonna be out of town. This will be my second memorial service of the month of October, which hopefully we're past that, but anyway, I'm out of town this weekend. But anyway, so as far as business that goes, announcements, next general meeting is November 21st. Is November 2nd still on for the public night?
Yes.
Yes. Okay. I guess that's always weather permitting.
Yeah.
Of course, we don't have a December meeting up here because we don't have a December meeting. I'm not sure, do we know when the holiday party is yet?
December 8th.
December 8th, okay.
I don't know the time.
And we'll, of
Yes.
course, as we get closer to that, we'll have announcements and stuff like that too. But yeah, that replaces the December meeting. So, are there any announcements? Any club business? Anything we need to say?
Just a little hats off to Russ for putting a run down the entire length of the roof.
Okay. I
I'm
would
trying
be-
to get that roof leak fixed.
Good. So yeah,
Yeah.
again, just to, Russ was able to get the materials together and actually do the labor to patch the roof on the.
He had two ground support that were pretty worthless, but
Yeah, I feel a little bit like I've been slacking, but you know, it's just been.
Moral support.
it's more of that than anything else.
Yeah, well, I unfortunately, this has just been like, for me, just a, hopefully we're coming to the end of it, but yeah, anyway. Next month, our speaker will be this fellow, Dr. Rob Zellum, who is a NASA project scientist and outreach scientist, and he's going to talk to us about the Exoplanet Watch program, which is a professional citizen science program that specializes in the measurement of exoplanet transits. So he'll be joining us next month. I virtually met him online, and seems like a pretty interesting guy and very enthusiastic. So I'm kind of looking forward to this. Of course, he'll be joining us by Zoom, or I guess Teams. Actually, he prefers Teams. So but he'll be joining us virtually. So that'll be the 21st of November, I believe. So I'm looking forward to this. I think this should be really good. We have two good speakers here, so you won't have to listen to me for at least another 2 months. And if anybody wants to volunteer to give a presentation in January, then that would be 3 more months. Then you don't have to listen to me. So let me know. All right. I thought I'd go ahead and do a constellation. I wasn't sure how our timing is. How long do you think you need for this?
I think mine's like about 40.
Okay. I think I'll go ahead and do this then, because I was thinking about, we often do a kind of a little focus on a constellation, and I've been trying to do constellations, number one, I haven't done before, and secondly, that I think are interesting, and thirdly, that are becoming more visible and more prominent. And so I thought about Pegasus, which is a constellation that I like a lot because I can find it. Constellations are a little bit tricky sometimes. It's, the problem is that I learned constellations from this old children's book called The Stars, and it would show you these little outlines, but it only showed you the stars that were in the constellation. And you think, oh, cool, I know that shape. And then you go outside and it's like, oh, there's all these stars. Which ones am I supposed to be looking at? This one is, I actually find it kind of easy to find because it has this feature in it called the Great Square, which is, aptly named because it's big and it's a square. And it's actually part of 2 constellations. Part of it's Andromeda, which we talked about a little while back in a meeting, which is, of course, an important mythological feature, and the other part is Pegasus. It's also a really big constellation, covers quite a lot of the sky, so it's interesting in that respect as well. One of the things I didn't realize, of course, there's Cygnus, which we talked about last time, so we're kind of working our way into fall here. One of the things I never realized about Pegasus was that I always just thought of Pegasus as not necessarily related to any particular mythology, right? It was just sort of this winged horse, this figure from, the mobile oil ads. And it turns out it actually has a relatively, at least to me, relatively interesting mythological link to it. And it has to do, of course, with, as ever, all the Greek gods who we end up talking about a lot because that's the source for a lot of the constellations. And of course, in mythology, Pegasus is this winged horse. It's actually an immortal horse, and has kind of an interesting origin story. This is a nice picture here. You can see, I'm assuming that's Mount Olympus in the background. Kind of an interesting story, really. It involves another character that we talked about a little more recently, Perseus, right? So Perseus is also kind of Hercules, right, and represented by a constellation. But Perseus, as you may remember, was the illegitimate son of Zeus and one of Zeus's many dalliances, and was not a particularly, therefore, popular to Zeus's wife, who sent Perseus on a bunch of labors, essentially, to try to get rid of him, right? The labors of Hercules, same, right? So one of the things that Perseus was sent out to do was kill the Medusa, right? The Medusa was this character with snaky head, and if you looked at it, you turned into stone. And so Perseus got some help on all this. One of the things he got was a mirrored shield, so he didn't have to look directly at the Medusa and would not be turned to stone. But he also got this golden braid, or this golden bridle, and it allowed him to essentially tame Pegasus, or it allowed him to, I'm getting a little ahead of myself here. So these things allowed him to slay the Medusa, right? He cut its head off and took the head back and showed it to the king that sent him on all this mission, and the king turned to stone, and Perseus became this hero. Anyway, it also allowed him to, it allowed the birth of Pegasus and his brother Chrysaor. This is another one of those weird family trees, right? Because Pegasus is a horse and Chrysaor is a person, but apparently they were siblings that were formed out of the blood of Medusa, which I'm not really sure how that happened. According to my book of mythology, the blood rained down on the earth, and then the earth sprang forth two siblings, one of whom was a horse with wings, and the other one was a person. Anyway, so the horse with wings became Pegasus. So here is the guy that got the other task. This is Bellerophon, and Bellerophon was given the task of defeating the Chimera, which is another mythological creature, right? And in order to help him, he was given this golden bridle that allowed him to tame Pegasus. And so he was able to tame and mount this mythical, fantastic winged horse, gave him a great advantage because now he could fly. So he could attack this beast from above, which the Chimera had no real defenses against. And that led to the slaying of the Chimera. On the strength of that, Bellerophon became quite a hero, became a favorite of the gods, as did Pegasus. They were kind of a team. Unfortunately, Bellerophon, fame did not sit well for him. Became quite arrogant and quite full of himself, and decided one day that he should in fact join the gods on Olympus. So he and Pegasus, he began to fly up to the top of Mount Olympus. Gods were not very happy about this because they thought, even though Bellerophon was a hero, he wasn't quite Mount Olympus worthy, basically. So they sent, of all things, a fly to take him down, a gadfly. So this term gadfly that you hear sometimes is sort of has its roots in this myth, right? And the gadfly came down and stung Pegasus, and Pegasus reacted as animals do to being stung by flies and bucked off Bellerophon, who fell to his death. Somewhat similar to what is the guy that flew too close to the sun?
Icarus?
Icarus, yeah. It reminded me a little bit of the Icarus myth. So Bellerophon was removed from life by his own hubris. Apparently, Pegasus was not included in this. Pegasus was sort of considered to be a unindicted co-conspirator and all this, not responsible for Bellerophon's action. So it was allowed to ascend to the top of Mount Olympus and join the gods up there, and in fact became quite a favorite of Zeus. So much so that Zeus made Pegasus the keeper of the thunderbolts. That was Zeus's MO in battle. He would throw thunderbolts, lightning bolts, and Zeus became. I love these paintings; they're so dramatic. He became Pegasus became the keeper of Zeus's thunderbolts and Zeus's steed during battle. So that's the mythological story, at least one of them. There's a lot of other ones. One of the things I always find with myths is when I start looking at it, there's usually other ones, but this is the one I think that, at least this is the one that was in my book of mythology that I get all this stuff out of. And so, in honor of all this, and in the honor of being Zeus's friend and carrier into battle and keeper of thunderbolts, Pegasus was enshrined with a constellation in the sky. So that is how Pegasus ended up in the night sky. There's actually a popular culture to Pegasus too, and again, this is something I didn't realize, right? But I don't know if you remember this, but Texaco and the Mobil Oil Corporation used Pegasus as one of their emblems, right? And so old Texaco stations, I don't think they do this anymore. I don't think they use this. I haven't seen it in a while, but they used Pegasus as one of their emblems, and therefore you see a lot of Pegasi, whatever you want to call them. You see a lot of these things in Dallas. There's a lot of like artwork because Dallas was a city that was the headquarters of this company, and so this is a neon depiction in Dallas. This thing down here, I included it. This is, you can ride the flying red horse, which always disappointed. There was one of these in the town my granddad lived in, literally one of these. And of course, we would always want to go down, and he would put a penny in it, and it would buck you back and forth for a little while, and that was, a pretty big deal when you're like 4. I was always super, super disappointed that it did not actually fly. But I can remember as a child actually being on one of these probably not this one, but one of these very things. So again, this is kind of invoked a little childhood, and I guess it was some sort of free advertising for Mobil Oil and Texaco. So anyway, so you do see a little bit of echoes of this in popular culture. This is one that I thought was really weird. This is a storage, like a disc bay, right? And it's called the Pegasus 32 Thunderbolt. So you get all of the Pegasus mythology contained in one computer accessory or one computer storage unit. Anyway, so as far as things you can kind of see in Pegasus, it's a really big constellation, so there's a lot of stuff in it. The more I read on that, the more I realized I can't really go through all this because that big of an area of the sky is going to have a lot of stuff in it. But there were a few things. These are some of the major stars and objects in it. Notice the name of the meanings, the Arabic words here, and they mean things like the nose and the upper arm and the saddle of the horse and so on. So these kind of represent the fact that even when these were being named, back in the Arab-speaking world, where a lot of the names of stars come from, they still recognized it as a horse, basically. Here's one of the first clusters I ever saw. Actually, this was in a introductory class I took in college, and this was one of the things. It was a class that was taught in the fall semester, and this is one of the first things we looked at. This is the only Messier object in Pegasus. It's the Great Cluster in the 15. Some really nice galaxies in it. Again, these are just some of the highlights. This was one that I thought was really interesting because you rarely ever see them totally face on like that. So this was a kind of an interesting galaxy that appeared, a nice barred spiral right there. Here's the thing, though, that kind of inspired me to, one of the things that inspired me to talk about Pegasus, right? Again, next week we're going to have or next month we're going to have a speaker who's going to talk about exoplanets. And 51 Pegasi b was the very first exoplanet discovered around a sun-like star. There was actually a discovery before, but it was around a neutron star, right? So this was the first one around a sun-like star. And it was a type of exoplanet called a hot Jupiter, which is a gas giant like Jupiter, but very, very close to its star. It was considered a little bit unusual or a little bit unexpected maybe when it was discovered, but the fact that it was so close to the star is probably one of the reasons why it was an early discovery, because these are just a little bit easier to detect than some other kinds of exoplanets. But if you want to look towards where it is, the star is, I believe, not. It's too faint to see with the unaided eye, but it's right there by the square. So that's 51 Pegasi, and this is the kind of an artist's representation of the planet. And of course, the discoverers of it in 2019 were awarded the Nobel Prize in Physics, which I understand was a little controversial, but I do not understand why, because I think this is probably one of the most important discoveries ever made, certainly in astronomy, but perhaps in science as well. But it's Didier Queloz and the guy whose name I'm forgetting, so I'm sorry for him. But these were two Swiss astronomers that detected this, so they received the Nobel Prize a few years back for this, and I personally think rightfully so. By the way, the third person that received the Nobel Prize that year was a guy named Jim Peebles, and some of you know, damn, my memory is not working so well today. Our sponsor from K-State. Yeah, he was he was a postdoc for Jim Peebles, so his postdoc mentor and his major professor were both Nobel Prize laureates, which I found kind of fascinating. Anyway, so with that, I will turn the floor over to our guest this evening, Sarah Lamb, who's going to talk about her adventures in Utah as a astronaut. So, Sarah, do you want the light off? At least a little bit of the lights on?
Yeah.
Maybe we can turn off at least a little bit of that. And I wasn't sure if I should introduce you as a candidate, but you are, right?
Yeah, I am.
Okay. So.
Yeah, I actually got my candidacy like 2 weeks before this trip.
Okay.
It was pretty hectic, actually.
I can imagine so.
Yeah. I'm Sarah Lamb. I'm a PhD student at KU. I did my bachelor's and master's at K-State. So I took this trip back in April for 2 weeks. I lived as an astronaut in the Utah desert.
Do you need a volunteer?
There we go. Okay, so this actually is not NASA funded. This is funded through the Mars Society, which is a nonprofit group, though sometimes NASA does like rent out their hub to send teachers out there or for other things, but usually NASA just uses other types of things, so I do want that clarified. So this is kind of in the middle of nowhere. It's in Hanksville, Utah. It's all the way out here. We actually fly into Grand Junction in Colorado and then drive along I-70 and then just come right here. So we are very remote. So this is Hanksville. It has a population of about 200 people. And then you have to come all the way out here to get to the Mars Desert Research Station. So it's pretty far away from civilization. And they definitely remind you, like, you are in a very rural location. There are not hospitals. If you have an emergency, they have to take you pretty fast to, like, Grand Junction or wherever, depending on the situation. So this is what it looks like from an aerial view. So this is the main hub that you'll see in a moment. Out here is our engineering lab. This is our greenhouse, the science lab, the astronomy observatory. At least I think that's the sun one that's remote controlled, so we don't walk out there. And then solar panels. And then out here is actually our outpost. So there is this like wall of rocks right here, so you can't see this from the hab. So the idea is that they don't exist unless you have an emergency. So they want them close by because they're the ones who have the cars, they're the ones who have like towing equipment, basically everything that you can kind of have. But the idea is that we only talk to them through email with like if possible, a delay, but sometimes that's not possible. There are radios if like we have like an actual emergency, but for the most part, we are to pretend they do not exist. They are solely there for like emergency purposes only. So this is a picture I took from a distance. I've climbed up on these kind of like mounds and knolls. So the reason this area was chosen is because it looks like some of the things that we've been seeing on Mars, so like that sedimentary rock that's been iron stained. So this is that observatory I was telling you about. That's, I think our commander, he's doing like a little project there. That's our science dome, the greenhouse, the hab, and then you can't really see our engineering lab. Right now I'm kind of doing some geology work out here, and then he is working with a robot that you will see later. So this was our crew. It's crew 297. So the reason this man is in a different color is because he was added on to our crew back in January. So like 3 months before we are sent out here. We're like an oddball crew because considering we didn't know anybody before like we went. We could talk on Zoom, but like we didn't actually know each other. Most of the crews are based on your university or lab group, so all 6 or 7 people that go already know each other and like have projects and plans that they've been working on for months. We all didn't know each other. We were all at different stages for the most part, and we kind of just like had to bring our own like short projects. We had someone drop out at last minute, so they had him sign in or fill in just because he's done this before. As you can see from his mini patches, he's done this, so he joined in at last minute. But this is Pavel. He was our commander. He works for Blue Origin. His background is aerospace engineering and I think biomedical engineering. This was Sean. He's a green hab officer, but his background actually is also engineering. This is Matt Storch, executive officer. I believe he's retired at the moment, but his background was also electrical engineering. Dave filled in as our journalist, but his background was also electrical engineering. Here's me. I'm the only woman, but also the only scientist of the whole crew. I think the scientist part actually was the bigger indicator, or like the bigger difference. And then this was Matt, who was like the actual person in charge of our engineering needs. His background is nuclear engineering. So this is our hab. This very first part is our airlock. And then the back door is here. This is our water tank that we are supposed to use for the entire 2 weeks. So we're actually, like in this picture, we're walking the back airlock. So these are our bathrooms. The toilet's in here, and then the shower and sink are in here. Here's burnable, non-burnable, and then there's like a mirror right here. If you just turn directly to your left, there is one set of spacesuits here. These are the one-piece spacesuits. And then this is all of our extravehicular activity gear. So we have GPS right here. We have walkie-talkies, radios. This is some of the gear that we just take out every day. So like the harnesses, the headsets, and everything like that. This is where we can actually like monitor where the GPSs are. So when the crew's in the field, you can see where they are in somewhat real time. The GPS definitely had some issues. So sometimes people would just like jump all of a sudden like hundreds of feet, and you're like, okay. This was our the mission control. He's the one who lives in the outpost that we pretend just doesn't exist. So this is day 1. He's just explaining to us like how all the radios work and making sure that we understand like what to do in case of emergencies and basically how to have a successful analog trip. So back here, this is our front airlock, and this is where we were hanging out hanging our flight suits up because we pretty much only wore them when we were like actually outside, and they were getting very dusty and just overall dirty. And here's the stairs that I think are death stairs that take you up to like our living quarters. These, you literally have to have your own special set of shoes to walk up and down them because you're not allowed to take your boots upstairs, but walking on these with socks will catch them, and you don't want to walk on them barefooted because I did that a few times. Oops, sorry. So coming up those death stairs, there are 6 bedrooms across here, and then there's like this weird like roof bedroom up there. And then this side is all of our like kitchen area. So we don't have a real fridge. You can kind of see it right there. It's basically a dorm room fridge for 6 of us. You weren't getting fresh food or leftovers. So here is our pantry. So almost all that we were given to start with. So they would give us things like a box of candy bars, raisins, basically shelf stable food. So there was a lot of freeze-dried food. So we got to test a lot of it to see like what's good, what's bad. This was our like last meal before we entered the simulation. Sean actually brought like avocados, tomatoes, and some other things, and we had like ceviche before we started. Yeah, you weren't getting a lot of fresh food there. These are the bedrooms. They are, I think, average like 4 by 11 feet, so they're kind of an odd area. There's basically 2 types. There's one where the bed's kind of closer to the floor, and then there's the bed that's above someone else. So while you do have like visual privacy, you can absolutely hear whoever's above you, or you can like feel the person beneath you when they would roll over in bed, and you're like, that's fun. And like the walls are just thick enough where you can't really just like pound on them and tell them to shut up. So it was kind of interesting because this was my bed and the whole thing would shake. So this is looking outside. So that's our engineering repair and maintenance module. And then here's our rovers that we are allowed to take out when we like go on missions. So you can see 2 of them are right here in the Curiosity rover. So there's Curiosity, Spirit, Perseverance, and I think Opportunity is at the other charger. So we can only have 3 of these. There actually is a Sojourner, but Sojourner, of course, has a dead battery or a worse battery, so it's like over by the outpost. So that's like their spare one. These are electric vehicles, so they do have to be plugged in, but we're only supposed to plug them in at night because in the daytime we're actually running off solar panel, but at night we switch over to battery power. Though that actually became an issue because I think 2 or 3 of the batteries like ruptured while we were there, and they are held in a science dome, and I actually didn't have any science that needed to be out there, so I was never in there. But apparently the ruptured batteries were giving off a lot of gases that they shouldn't have that was toxic, and that was the one time we saw our mission control guy because we were having all these power outages, and he's like, we might have to cancel the mission, the simulation, unless we figure this out. They figured out it was our batteries going, and he's like, we need those out now before this becomes like an emergency. So he showed up and had to have one of our people like go out to like the science dome and like literally remove the batteries and get them out. So here's our greenhouse. All of this was here before we stepped foot. Because this is day 1. We haven't even really started. But we were the last crew that had the greenhouse because we were already in late April and things were starting to get really warm. So there was going to be one more crew after us, I think, but they said break this whole thing down because it's going to be too hot. And it even got a little too hot when we were there. So we had to constantly be opening up these, there was window panels up here. Here is the science dome, not that I used it, but if you have pipettes, there's a stirrer somewhere, a microscope, a microwave. So I don't know if anyone really knows the Mean Girl references, but in the movie, the girl's like, get in, loser, we're going shopping. So I made the guys put post for this picture where it says "Get in, losers, we're going on an EVA," which stands for extravehicular activity. So this is the only time we're allowed outside. We have to be fully suited up. So we have these packs here that they don't hold oxygen, they're just fans, but they're connected to wires to our helmet. Sorry, not wires, but like pumps or hoses. And it keeps you cool, but also pulls the carbon dioxide out. So for an EVA, you put on your flight suit. That's the very first thing. I think this one is mine, not that you can really tell. But we all had this patch here. This is the Mars patch. So it's like Earth is sending life to Mars, so that's the general symbology. The American flag, of course, even though we didn't notice it till later, but whoever sent the patches did not put 50 stars on it. And then it says, I'm Lamb, crew geologist, and then here's our patch. So MDRS, so Mars Desert Research Station, crew 297, and then like our last names, and then our crew we decided to call Janus 1, even though I'll be honest, we kind of all forgot that we were called Janus 1, we just kept going by our number of 297. So here's like the Utah desert in the background, here's like the whole HAB environment. There's a trash can here that I'll talk about in a moment, the robot, and then there's this astronaut who's supposed to be me climbing up with this portable spectrometer I have. So everyone got a radio, 1 through 6. These were actually to communicate between buildings in the HAB. These are not for like really going outside. We can also contact mission control if we needed something badly. Then everyone who went out took a GPS tracker. And then in here was our headset and vests. So there's 2 types of suits. One is the EVAs. So down here is the one like built for petite people, which I took. The other thing is, since I was a geologist, I had to like bend down and stand up a lot, and I thought it'd be easier with like the really light one. That one malfunctioned, and I will get to that in a moment. This is Dave and Matt pulling off the back of my spacesuit. So you can see it was like, I think the very first one they've ever designed. So this is literally just a hefty plastic container, and they like drilled holes out of it to pump air into the overall helmet, and then there's 2 fans and a battery. There were issues with both the battery and both fans, so the whole thing malfunctioned. They switched out the battery once, and then there were still issues, so they realized there were also bad connections with the wire. Here's our 2-piece EVA suit. So the helmets sit in bags until you're ready for them, and then here's your fan controls, your ventilation hoses and connections. And a lot of this is like a 2-person job, especially the 2-piece ones. It's really hard to get those hoses connected by yourself. And basically the moment you put it on, you can feel it start to rise in the helmet and the carbon dioxide start to like pile up. You can feel it almost instantly. So you really need someone there like the moment that goes on that the hoses are being attached. Most of us were wearing head caps just to keep our hair and headset in place. It's not fun with those headsets that are like moving around because you can't adjust them once they're moved. There's also a mic on the headset, which is the most annoying thing that would move around. Here's our like vests that we would wear. So our radio would be in one pocket and GPS in the other, gloves, and then the whole like backpack. So they did have us go into the airlocks for 5 minutes, just so like we could simulate pressurizing and depressurizing. And these radios are connected to the ones right around the door. So even if you want to like chat with your the people going out on the EVA mission with you, the whole crew can hear you. So sometimes you just kind of stood there silently until you were like ready and further off and able to switch to channels, so the rest of the crew didn't hear like all of your just mundane talk or jokes. So we had our own personal like HabCom person, so someone who like was talking to the crew members at any given time. I think Pavel, our commander, did it the most times, but I did it like the second most, just because it was decent work. Basically, you just had to check in with them every 15 minutes to make sure that nothing's gone wrong, unless they were in a blackout zone, and then you just did nothing. So it really wasn't too hard. And if they did have anything on the radio, you would just like note it down, like the GPS locations, what they've seen, what they saw, etc. And these can go actually pretty fast, so we were able to like drive around the area in this. So here is me, and I'm starting to do some of the like geology work just to see like what rocks are around. My project was a very last minute thing. My original plan was I was going to take a Raman spectrometer out into the field. And Raman spectroscopy is what I do for my PhD. It tells you about the mineralogy. The Raman I was going to borrow was broken. The backup one I asked about was broken. Then I think there was like a third one that was broken, and then I think someone eventually could find a fourth one, but there was no way to get the paperwork and the shipping done in time. So we had to scrap that whole thing, and I'm kind of sad because if it had worked, I was going to like add it into my PhD, but it is what it is. So I was able to contact the Kansas Geological Survey and get a gamma ray spectrometer, which tells you radioactive potassium, uranium, and thorium. And I'll be honest, I learned real fast of what all that meant, and I've already forgotten it because it's just not something I do. But if I remember correctly, it tells you some of it's like oxidation, what's been reduced, what's oxidized, but it also can tell you roughly what kind of minerals you're dealing with. So I found that I was mostly dealing with, at least in that area, reduced clay minerals, and then down here I have oxidized clay minerals. I think there was some more to it, but I've forgotten, if I'm being honest. So I brought these little straps for my arm. That way there wasn't a gap. Originally I was going to write notes to myself on them, and then I just didn't. But, so that's the gamma ray spectrometer. That's my rock hammer. You can see on my belt is where I keep like my notebook. Right here you can see someone's digging a hole, which okay, we'll get to that in a moment. I thought it was the next slide. So Pavel, his project was CASE. So this is a robot. These engineers from CU Boulder are trying to basically design a robot that can help astronauts in the field. The problem is they didn't ask any scientists before they did it. So they're like, would you use this? I'm like, I don't know what you would use it for. You have nothing attached to it. It's just a robot with a camera. I can walk faster than it. So here's CASE. So they were kind of like remaking things from The Martian and seeing how quickly CASE can turn around, how good the camera is, how easy it is to drive. Could this take mapping data by itself? How well did it all work? And then Dave, who's been here before, his project, I believe, is a sonar, and it was to calculate how much water was left in this whole tub. So it's actually Matt's job as our engineer to calculate how much water there is, but you have to use like a ruler or measuring tape and like stick it down in there, and apparently in the past people have like accidentally dropped the ruler or measuring tape in there, so it like would contaminate the water or it'd be very difficult to get out. So his project was trying to calculate how much water is still in there. So to the digging holes and trash can. So this was Matt's project. Matt's project, since he's a nuclear engineer, he was thinking about how do you get nuclear power safely on Mars? And basically their whole thought is this nuclear power, which we are representing as a trash can, is going to be sent to Mars without the astronauts. They're going to be sent separately. So how well can we find a trash can on Mars? So we would actually play hide and seek. So one team would go out, hide the trash can, we would scramble the GPS coordinates, give it to the next team, and then they would go have to find, and I think like we kept adding the radius bigger, but it was like a 200 meteor radius. How quickly can you find the trash can? How quickly can you find it in 300? and it just keeps getting bigger and bigger. So that was one part of like how well can you find this trash can, the nuclear power source. The other part was, okay, so the astronauts, you know, we find the trash can. How quickly could you actually dig on Mars to bury it? Because theoretically, that's going to be a buried source. So here's us digging holes. I only had to help dig once. Usually I was off somewhere else, and all the guys were digging holes. So here's just a basic map. So here is MDRS, that's our HAB. There's some rocks down here, some stuff we did up here. But a lot of this, we kind of just stayed on the paths for the most part, or we were trying to just see, based on color, what looked most interesting. So we took 2 trips out here because there's like this sea of gray. We did like 1 trip down this route, and then another time we came all the way over here because we wanted to get into like this canyon valley. But this is sort of like what it looks like. They would drop the trash can there, and then I would scramble the GPS and then put this radius and say it's somewhere in here, and then they would have to go find it. That's the other reason I was normally the person on HabCom, because I could watch the GPSs and I knew how close or far away they were from the trash can at any given moment. And sometimes I would taunt them over the radio of how far they were. So injuries. This is like thing from the second day we were out. The guys were just playing around digging the hole, and I was like, oh, that's a different kind of mineral at the bottom there. Let me use the gamma ray spectrometer. And I'm kneeling on the side of it, and it just collapses because it's not consolidated out there. It's clay minerals. So I am able to like twist fast enough so I don't like face plant right into the ground. But I did that. I like pulled something like in my shoulder and back. And the guys are taking pictures because they're like, oh, we just thought you meant to fall like that. I was like, no, I did not. And you can see in these pictures, I'm wearing different spacesuits. This one malfunctioned. One of the days we were there, I think it was maybe the second or third day, so I've already injured my back from falling. All of a sudden, this started getting really hot. So we're in the desert, we're in April. I can just feel everything getting really, really hot. I'm like, okay, it's like a little hotter than normal, but we are all bundled up in these field suits, or flight suits. And I realized that my fan is just not working. And I was like, okay, we need to get back to the HAB now. So we ended things right then and there, got in, and we got me back, but because of just how long of a drive it was, I actually had heat exhaustion. And it was bad enough where the estimate was if I had been out there for like 10 to 15 more minutes, I probably would have had heat stroke. And then the real dumb question was asked, we're like, you know you're not on Mars, so why didn't you just take it off? And somehow that didn't cross any of our minds because we are just so focused of like, you don't break protocol. And someone's like, you guys aren't on Mars, this is a safety concern. So that's always nice to be reminded of that. And then that's the first day. So that's when the guys broke open the back of it, placed the battery, do everything like that. They put it back, sealed it, and I think one day in between, so I had the heat exhaustion, and then I switched to one of these for a day, and I mean, they had me back out in the field the very next day. This is, I think, 20 pounds heavier than this one, so I'm already in a weakened state, and I go back out in the field with something even heavier. I was not productive that day. I actually did very little. I was like, guys, it was a bad idea to bring me out here, but I'll just like sit here for support. So once they had fixed that, I took it back, put it back on, and then it was this day, so we're out in this kind of like gray, hilly area, and it was in the early morning, so it was actually very cool, but I could feel that there was carbon dioxide starting to collect in my helmet. So I did start cheating. I actually would just like grab that and just like push it far away so I could like breathe. And I was like, it's not bad enough we have to like go back, but this needs to be like decommissioned. So that was the end of that spacesuit. from then on out, I had to be in this one the remainder of the time. So these are just different photos. So this was that great, like, canyon valley that we wanted to get to, and this was kind of the only place that you could walk down into it. Here we are on the top of this like mound that's near the Hab. This picture is supposed to be a recreation of our patch, so it's like me, the astronaut, and the spectrometer like walking with the Hab in the distance. So that little white dot, that's the Hab. We actually had a lot of free time. We had more than I kind of expected. And at no point did they shut off our Wi-Fi, even though they said they were going to. They said that they were going to shut off our Wi-Fi except between the hours of like 6 and 9. So that would be like when Mission Control would open up, and then we would talk to them through email and be like, this is what we did for the day, this is what we plan to do tomorrow, etc., etc. But then they just never shut off our Wi-Fi. So I think for the most part, people tried to stay off the Wi-Fi. But I know some people were definitely like downloading like movies, papers, etc. But we played a lot of card games with each other. I actually took like an old school Game Boy Color. I didn't know how well I would do psychologically. I assumed I'd do well, but I wanted to pretend I was on Mars, so I took like little mementos. So I liked those cheesy smashed pennies you get at tourist places. I love those, so I took my little penny passport. I had like a challenge coin, I think from Johnson Space Center, that says Mars on one side. This challenge coin is actually from my internships at Los Alamos National Laboratory when I was on the Curiosity rover team. So it was for the 75th anniversary of the lab. My old school Game Boy Color with games. So that's like a little Pokemon figurine. It's hard to tell, but this is a like an epoxy turtle that has fake opal flecks in it. So my PhD is on opal, so I took that. Yeah, just like small mementos. And this is just a nice photo that I like. I didn't realize my camera could do this well. I mean, I know it's not that great, but it was better than I expected. So this is just the Hab right here. That's our greenhouse. So to my back is the astronomy tower. And you can see a lot of stars at night out there. So it's great. There's almost no light pollution. Even from Hanksville, when you're there, there's pretty much no light pollution. There's only 200 people. Yeah. Yeah, and here's just like one last photo of that canyon region that we were in. But yeah, so I think the rest of the time I have just for questions, because I know there's probably lots of things that I haven't covered, but you might be more interested in or less interested in.
Questions?
How'd you get chosen for that? Do you remember? Did your name go into a pool, or was did you volunteer?
So I did have to volunteer or apply. So anyone can apply, and it just depends on what year. Like some years are more competitive than others. I think he said, I forget if my year was competitive, but the next year wasn't, or the vice versa. But they generally pick like universities crews, but they do have like every once in a while like two oddball teams, just people who are just assembled. And again, you don't have to be a current student. It does cost to go though. I think it's $2,000 for students, $3,000 for professionals. But yeah, and you would just tell them like, what are you able to do, capable of? So I said I could be the crew geologist, generic crew scientist, because they had those listed as if they were separate positions. And I think I also said I could be the journalist. But you were allowed to say that. And then they'll ask you kind of questions. They're like, can you cook? Do you work well with others? How do you do without Wi-Fi or isolation or things of that nature? Oh, there's something I did forget. We didn't get psychologically tested to go there, but we were psychologically tested while we were there. So it was interesting because they would ask you questions like on a scale to like, I think 1 to 10 or 1 to 100, like how bad was today? And I actually marked everything like pretty low, except the day I got the heat exhaustion, and then I was like, oh, that's like a 4 out of 10. And then you had to have like a interview afterwards with someone like in person, not just like one of the surveys. And they asked me about like how it was, and I was like, oh, that's really peaceful. And they're like, most people think it's very stressful. I was like, oh, my life is stressful and busy. I had like 2 weeks of peace. This is like the closest thing I've had to a vacation because I told people don't bother me and they listened. Plus I told them I wasn't gonna have Wi-Fi. So I actually found this to be extremely relaxing and peaceful. It was very nice. Apparently most people do not think that. They don't like the separation from their families, their friends, worried about like what else is going on in life. So, yeah.
When do you think the time frame is coming where there'll actually be a human mission to Mars?
I don't know, because I think a lot of that comes down to money and politics, so I don't know if it's a technology question. I think theoretically the technology exists in some capacity. It's just going to be who funds it and who, yeah. Politics and money I think is going to come down to it. So.
The data that you collect of these things, is it turned over to NASA or shared with NASA?
For mine, no. Other people's are, like, I think the psychological one, they have like an actual grant, and they've been doing this for like so many crews, so that is going to get shared with NASA. Mine, I don't think I did enough data collection. It was only a couple hours in the field with an instrument I actually was not particularly familiar with, so I basically, plus geologists have been up and down this area. So my whole angle was just, is gamma ray spectrometer useful and practical for astronauts? And I came to the conclusion of, yes, it's useful, yes, it's practical, but if you have something better, choose it. But I actually found that it was an extremely durable instrument. Like I fell and like smashed it into the ground and it still worked. I climbed up a mountain one-handed and it like got bounced around and it still works. So again, I theoretically think there are better instruments, but I don't know if there's any going to be as, like, you have to make these durable. So I guess, I know it's kind of wishy-washy of an answer. Like, if you have nothing better, then yeah, gamma ray spectrometer all the way, but if you have something better, maybe not. I don't know if it gave me enough data.
When you did communicate out, was there a delay in the response?
No, they're hoping to do that in the future, like get the systems where there's actually like a 20-minute delay or however much they set it for. But no, there was no delay with email, so. They did say that if you wanted to be practical, so like if you did email like your family or whatever, like don't read your emails for 20 minutes. So they did tell you to do that, but they also said it's up to you. They're not going to police us. So what you get out of it is, or what you put into it is what you're going to get out of it. Yeah.
I don't know if this happened. It sounds like it didn't happen to you, but has there ever been a case when people have been out there and it's rained?
Huh? That happened as we were leaving. So like we had already ended the simulation, and it is just absolutely pouring down. And we're like trying to clean up the hab, and they like tell us to go clean up the science dome, which you have to go outside to get into, and none of us were really in there. So I actually tracked more mud getting in there just to clean it up, and I was like, this is insane. Like, we weren't in here. So that made it really challenging, and one guy drove here. So he's trying to like bring his car all the way around, and he gets stuck, so they had to go get a different vehicle to come pull him out. So yeah, you don't want to be out there when it rains, or if you do, you don't want to be leaving when it rains, because it is just absolute mud slush.
Yeah, they could really run a mission and not be a good simulation of Mars.
Right.
I mean, I don't know if this is anything that comes out of all this, but you know, if you were using something like the gamma ray spectrometer or something, you couldn't just take one to Mars. I mean, the displays would freeze, wouldn't
I don't know how well I don't know how low those temperatures can get for a gamma ray spectrometer. I'm assuming they would have to specifically build one for Mars.
they? Yeah, I would imagine.
I think it could be done though.
I think anything with a liquid crystal display would freeze.
Right. So.
Where a thunderstorm was.
Okay. Wonderful.
Yeah, there was some nice light, there was some nice lightning up to the west.
Yeah, again, originally I was gonna take a whole different laser, but maybe better I didn't, because that one's apparently very finicky and breaks all the time without trying to go into the true field.
Yeah.
You know, you mentioned use of GPS for Mars. You know, I would assume that they would have to have different parameters on that and the communication satellites to be able to triangulate and so forth.
So Mars is one of the few planets that we do have like a grid system, but that's because we have so many orbiters that have been around it. So yeah, GPS on Mars could be done. It's not going to be clearly as good as Earth, but it could be done to some precision in real time. But for communication between Earth and Mars, is that what you mean? That's not done in real time. They're too far away from each other.
No, I was thinking more in terms of you know, location on Mars, you know, where you are in the grids that you have and so forth.
My guess is that if we start sending humans to Mars, they're going to really pump up how many orbiters are around Mars at the same time. So I think communication, again, I'm not going to say it's going to be perfect, but I'm going to assume it's going to be pretty decent just because the mission support is going to have to follow.
So do you think then those orbiters are gonna have some GPS capability like they do that go around Earth? In other words, they, as a multifunction device where they would have that GPS, at least some course.
Yeah. I think to some level they would have to do it.
Yeah.
And CubeSats are becoming much more
Yeah,
popular.
right.
So I do think that's a real possibility. And I assume it has to be somewhere already planned for.
I was a little puzzled on the search for the
Trash can?
for the trash can.
So was I. It's okay.
Yeah, I would think that something like that they would have some form of a transmitter on it where you could go out with two radios and just do some triangulation.
Right. That's what I would think too. Besides, like, we do know to a very confident degree of like where Perseverance landed, where all these other things landed. So I assume like we would know where the astronauts landed versus where the trash can landed. There wouldn't really be a true search, especially again, we have so many orbiters taking pictures. Like we can see Perseverance on the ground. It wasn't my project. I kept quiet about my thoughts. I also was very quiet. I'm like, just because this looks like Mars does not mean this is the Mars substrate, so I don't think we can assume anything about like digging on Mars. But once again, it was not my project. I just helped hide things. And in this one time I helped dig.
You never went to find it?
Actually I did a few times. But I was generally more for like hiding it. And then I was the one who was like scrambling the GPS signals because I had ArcGIS on my computer.
What kind of rock samples were you able to get?
There was some quartz. You can kind of see a lot of this is just clay and unconsolidated. So there's a lot of, I believe it was smectite that was in here. There's definitely shale out there. You can find green shale. If you go really far out, you can get like darker shale that has uranium in it and likely organics. But a lot of this out here had just no uranium in it. It had all been likely taken somewhere else.
What geologic formations are those? Chinle or Moenkopi or?
I think it's closer to Chinle. I don't think it's Moenkopi.
I can't remember the exact order.
I don't know, honestly. I thought Moenkopi might have been kind of higher up,
Yeah,
but
I was gonna say, it's not high enough for Moenkopi.
I wouldn't think so. Because this is, I mean, I actually was just in Arizona at the Meteor Crater, and Moenkopi sits pretty high. So, and I didn't see any limestone underneath any of this, so.
There's some Moenkopi exposures to the south of here, like down Canyonlands and all that. I think they get into some.
But aren't they like still higher
Oh, yeah,
elevation?
definitely.
Yeah, I was gonna say, I think we're too low for that. I mean, we are on the San Rafael Swell, or like parts of the Colorado Plateau. It's really starting to come down.
Martian tail. No simulated dust storms?
No, not really, but at one point we did see like a little bit of dust coming up, but then it kind of just like petered out.
Has there been any discussion of timeline in terms of going to Mars?
Yeah, there's been lots of discussions, but a lot of that comes down to money and politics, but also Artemis program. They aren't really going to make movements on Mars until they have Artemis sorted out, and even that seems like that timeline's getting pushed back.
Yeah, I've been in the Artemis meetings for the past several years, and the interesting thing is they keep bringing up, you know, this also means we're going to Mars. It's gonna be the same systems
Right.
that are going to Mars that are going to the moon.
Yeah. Yeah, so I don't even know how to answer that question because politics, money, but also Artemis, they're not going to make real decisions till Artemis is sorted out.
Right.
So could that be in like early 2030s? Could that be in early 2040s? I have no idea.
At least that's the talk they give in the meetings.
Oh yeah. Yeah.
But even Artemis, like you say, is still in the early stages, so.
Yeah.
How clean was the sand and the dust?
Actually, it really wasn't too bad. Well, I felt like this red dust cleaned a lot more, but it was also significantly finer grained than the white dust
Yeah,
was.
the reason I asked the question is that it's my understanding that dust management is going to be a real problem on the moon and on Mars, and I was wondering if they had you practice anything along those lines.
No, but it is something we like briefly talked about if we could do things like in that airlock, if we could put like the sticky floor paper that you use for clean rooms, if you could put like one of those small robot vacuums down there to like pick things up, if we should saran wrap like the area between our gloves and our like the end of our flight suits, because I think I was told one of the main issues is like getting gloves on and off, like probably also helmets, but one of the biggest things is the glove issue. So if we could like saran wrap that, granted that's disposable and you're now adding waste, but does that help with dust? We talked about a lot of ideas, and a lot of it ended up just being like we really didn't have time to develop these really large scale plots. Oh, another one we talked about was taking like a vacuum cleaner or like the top of it, so what maybe one of the portable ones where you can pull off the handle and putting it on the floor, and then having it connected to one of those kind of like Christmas lights extension cords that where you like hit the button with your foot. That way you, oh, and then you also take like a shoe brush. So the vacuum's attached to the shoe brush, and all that's connected to like one of those extension cords where you hit the button. So you'd be like, you would hit it with your foot and then brush one boot off and then brush the other boot off. So it's all contained, or contained as you can get. But yeah, dust is going to be an issue no matter what. And the dust on the moon and Mars is going to be significantly worse with their atmospheres. That electrostatic is much bigger issue.
Did you guys discuss the mission length if there is a mission to Mars? It wouldn't be a few weeks.
So, not with them. I have not discussed this, but I actually have discussed this with former astronaut Steve Hawley from KU, because he was on some of those meetings before, and basically, I mean, granted, he said this was a while back, but at the time, they basically come down to the decision of, you send astronauts there for a month planning that something's gonna go wrong, and they're actually gonna be there for a year. So, because just based on orbital patterns, your choice is essentially, I think he said like a month or you're stuck there for a year. So, you know, plan for a month, prep for a year.
Wow.
One-way trip.
Yeah.
Do you want to go to Mars?
I prefer to go to the moon, but that's more my style. I like two-way trips. But
Like being able to see Earth?
yeah. Oh, yeah. I mean, a year on the moon would be fine, I think. Well, then you have to deal with like black gravity. So I don't know. Maybe that would be worse than a year on Mars, but I don't know.
It's like an awfully long time.
So gravity on Mars about 30% of Earth? Or
16.
Yeah. Wait.
16.
That's for the moon, right?
oh wow.
I don't know. I just was looking this up because I asked a
I
question.
I
asked
thought-
an exam question where they had to know
Yeah, I thought he was right. I think it's like a third
Is it?
for Mars, and the moon is, I thought what you just said, 16.
let's look.
1/6 or something.
Yeah,
It makes moving heavy things a little easier.
yeah.
So we get back on.
Yeah. It's heavy. There's a word heavy.
3.7 meters per second squared, so about a third.
Yeah.
Good.
Yeah.
38%.
I don't know. I don't think I would want to be the first person on Mars. I'll let someone else do that. I guess there's lots of concerns, but one of my bigger ones is like getting off Mars because that atmosphere is no joke. Like it's bad enough trying to get into it because like while it's not that thick, it's thick enough to burn things up. So my big concern would be getting off Mars than just like being there. So the moon's a little more tried and true, and also less atmosphere.
So what's next for you after you defend your dissertation?
Well, that's still in a few years. What's next? Theoretically, it's going to be a postdoc. I'm looking at like the USGS astrogeology out of Flagstaff. A few people at NASA, mostly NASA Johnson, so in Houston, but also NASA Goddard out of Maryland. I have actually worked for NASA JPL, but I think my interests lie a lot more with like what Goddard has to offer or Johnson has to offer. Honestly, there's just a lot going on, so kind of have to just take it 1 month at a time.
Any further questions? Well, let's thank Sarah. Okay. I guess that's it.
But we need to do some
Thank
other
you.
stuff because it's still raining.